Good morning, children. Today we shall learn how an electric bell works. Most of us have seen it. You know, this bell also works on electromagnet. Confused? Let us first refresh our memories. We already know when the electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Also, a current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. The power of this electromagnet can be increased by increasing the number of turns of the coil. It can also be increased by increasing the flow of current through the coil. Let us also not forget, electromagnet can also be turned off by stopping the electric flow of current which made it a magnet. Now that we are clear about the electromagnet, let us now understand how an electromagnet is used in the functioning of an electric bell. Let us see the simplified circuit of an electric bell with the switch in off position. It consists of a coil of wire wound on an iron piece bent to form U-shape like a horseshoe magnet. A spring-loaded arm made of an iron strip is kept close to the electromagnet. This arm has a hammer attached to it at one end. Let us call it a clapper. A small gong or bell is also placed near the hammer. See, there is a contact screw near the clapper. Now let us switch on the circuit and the fun begins. Right now the clapper is in the contact with the screw, so the circuit is complete and the current flows through the coil. Due to the current flow, the coil becomes an electromagnet. The electromagnet then pulls the clapper towards itself. In this process, the hammer at the end of the clapper strikes the gong of the bell to produce a sound. Let us see what else happened when the electromagnet pulled the clapper and we heard the hammer striking the gong. Look closely. Right now, the clapper is not in contact with the screw. The circuit is broken now. So what will happen next? The current through the coil will stop flowing. Will the coil remain an electromagnet? No, it wouldn't. The coil is no longer an electromagnet. As we know, it's the flow of the current that gives the coil its magnetic power. So, it no longer attracts the clapper. The clapper springs away from the bell back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated again and again very quickly. Thus, the hammer strikes the gong every time the circuit is completed. This is how the bell rings. Interesting application of an electromagnet, isn't it? So, in a nutshell, by turning an electromagnet on and off, we made a useful thing, an electric bell. Using this electromagnet, we created the movement of the clapper to ring the bell. With the current flow, the electromagnet attracted the clapper, ringing the bell. But it also broke the circuit and stopped the current flow. Due to this, the electromagnet lost its magnetic power and the clapper went back to its original position, making the contact with the screw again. This made the circuit complete and again the clapper struck the gong. Great, isn't it? So the next time if you get any chance, do analyze the circuit of an electric bell. See you next time. Till then, have fun. Bye bye kids.